Welcome to the fascinating world of armature winding. It's a craft, a skill, and an essential service that keeps industries humming and economies moving. This isn't just about wires and motors, it's about understanding the very heartbeat of the machines that power our lives. This is the job that keeps the world spinning, literally. From the smallest gadgets to the largest industrial complexes, electric motors are the unsung heroes. And when they falter, when they break down, the world feels the impact. The armature is the heart of every electric motor, the core component around which the entire operation revolves. It's a carefully constructed assembly of coils and conductors designed to interact with magnetic fields and generate the rotational force that drives countless machines. From your blender, quietly whirring in your kitchen, to massive industrial fans, tirelessly circulating air in sprawling factories. The principles are the same, the scale may differ, but the need for skilled maintenance remains constant. As an armature winder, you're the one who brings dead machines back to life. You're the restorer, the rejuvenator, the vital link in the chain that keeps everything running smoothly. It's hands-on, gritty work. You'll be getting your hands dirty, working with tools, and diving deep into the inner workings of these complex machines. Part mechanic, understanding the physical structure and operation of the motor. Part electrician, tracing circuits, testing conductivity, and ensuring the flow of power is precise and reliable. All problem solver. You'll be diagnosing issues, identifying faults, and devising solutions to get things back up and running. You'll get dirty, you'll get tired, pushing your physical and mental limits to meet deadlines and overcome challenges. But you'll also get the satisfaction of seeing a silent machine roar back to life, knowing that your skills and efforts have made a tangible difference. When motors fail, production stops. Assembly lines grind to a halt, critical systems shut down, and businesses face costly downtime. That's when you step in, the expert called upon to diagnose the problem and implement the repair. You're not just wrapping wire, it's more than a repetitive task. You're restoring power and keeping the world moving. You're ensuring that factories can continue producing goods, hospitals can maintain critical life support systems, and transportation networks can keep people and products flowing. This skill is timeless. Motors will always need winding. As long as we rely on electric power, there will be a demand for skilled armature winders to keep these essential machines in operation. If you want a career that's essential and hands-on, a career where your skills are valued and your contributions are tangible, you're in the right place. We'll break down the tools, the techniques, from the simplest hand tools to the most sophisticated testing equipment, and the secrets of the trade, passed down through generations of skilled craftsmen. We'll guide you through the process step by step, until you have the knowledge and confidence to tackle any motor repair challenge. It's not glamorous with no red carpets or flashing lights, but it's vital. It's the backbone of industry, the unsung work that keeps the modern world turning. So, roll up your sleeves, prepare to get your hands dirty, and let's get started on this journey into the world of armature winding. In this trade, your tools aren't just objects, they're your lifeline, your companions in the intricate dance of motor repair. They are the extensions of your skill, the interpreters of your intent. You'll need a comprehensive set of wrenches, in both metric and imperial sizes, to tackle any bolt or nut that dares to cross your path. Screwdrivers, a variety of them, from flatheads to Phillips, stubby to long reach, each designed for a specific purpose. Pliers in their many forms, needle nose for delicate work, linemans for heavy-duty gripping, and side cutters for snipping wires with precision, and of course, a trusty hammer. Not just for brute force, but for gentle persuasion when things get stubborn. And crucially, always remember insulated handles for electrical safety. Electricity is an invisible force, and respect for it is paramount. Insulated tools are your shield against potential harm. Power tools like cordless drills are indispensable for efficiency. They transform time-consuming manual tasks into swift operations, allowing you to focus on the more intricate aspects of the repair. Angle grinders and bench grinders are also essential, saving your back and your time by making light work of cutting, shaping, and sharpening metal components. These tools are force multipliers, amplifying your capabilities. When it comes to winding coils, a coil winder is not just helpful, it's your best friend. It ensures consistent and precise windings, crucial for motor performance. Think of it as a lathe for wire, meticulously layering each strand to create a functional and efficient coil. It's a specialized tool that elevates your winding game. Always respect your tools. they can bite if you're careless. Safety glasses, gloves, and proper handling techniques are non-negotiable. A moment of carelessness can lead to lasting consequences. Clean and maintain them regularly. Wipe away grime, oil, and debris after each use. Sharp tools are safer and more reliable. Dull blades require more force, increasing the risk of slippage and injury. Keep your cutting edges honed and ready. Specialized tools matter immensely. They are designed for specific tasks, making complex procedures simpler and more accurate. Bearing pullers, for example, allow you to remove bearings without damaging the surrounding components. Growlers are indispensable for testing armatures, detecting shorts and open circuits that would otherwise be invisible. And meggers are crucial for insulation checks, ensuring that the motor windings are properly insulated and safe to operate. These aren't your average garage tools, they're precision instruments designed for the demanding world of motor repair. They're essential for accurately diagnosing and efficiently fixing motors, ensuring optimal performance and longevity. Learn their quirks, understand their limitations, treat them well, and they'll never let you down. They will become extensions of your expertise. After a long day of hard work, take a moment to wipe them down, inspect them for any signs of damage, and store them properly. A well-kept toolkit is not just a sign of professionalism, it's a reflection of your commitment to quality and precision. Know your tools intimately, and you'll work faster, safer, and smarter, delivering superior results with every repair. They're your trusted partners in every repair, your allies in the quest to keep motors running smoothly and efficiently. Before you even think about fixing a motor, diving into the repair process, or troubleshooting any issues, it's absolutely essential to understand what makes it tick. We're talking about getting intimately familiar with its inner workings. You need to know its anatomy. Think of it like this: a doctor wouldn't perform surgery without a thorough understanding of the human body, right? Similarly, you can't effectively repair a motor without knowing each component and its specific role. The stator is the stationary frame. It's the backbone of the motor, providing the structural support for all the other components. It houses the windings that generate the magnetic field. The armature, or rotor, spins inside it. This is the part that actually rotates, driven by the interaction of magnetic fields. The rotor's movement is what ultimately powers the device the motor is connected to. The armature has a steel core. This core is made up of thin, stacked laminations. These laminations help to reduce energy losses due to eddy currents, making the motor more efficient. Slots for windings. These slots provide a secure and organized space for the copper windings to be placed. The precise placement of these windings is crucial for the motor's performance. A commutator. The commutator is a vital component in DC motors. It acts as a rotary electrical switch, reversing the current in the armature windings to keep the motor spinning in the same direction. And a shaft. The shaft is the rotating rod that extends from the motor and transmits the mechanical power to the driven device. It needs to be strong and precisely aligned. Windings are insulated copper wires. These windings are the heart of the motor's electromagnetic system. When electricity flows through them, they create a magnetic field that interacts with the stator's magnetic field, causing the rotor to spin. Get the gauge and placement right, or nothing works. The thickness of the wire, gauge, and the precise way it's wound around the core are critical for achieving the desired motor speed and torque. Bearings let the shaft spin smoothly. These bearings minimize friction, allowing the rotor to spin freely and efficiently. Different types of bearings are used depending on the motor's application and load requirements. Brushes deliver electricity to the commutator. These brushes are typically made of carbon and are designed to wear down over time. Regular inspection and replacement are essential for maintaining motor performance. Handle everything with care. Motors are precision machines, and even a small amount of mishandling can lead to damage and performance issues. Drop a core or scratch a commutator, and you're in trouble. These seemingly minor damages can disrupt the motor's electrical and mechanical balance, leading to reduced efficiency or complete failure. Damaged insulation or bent laminations mean shorts and failures. Insulation prevents electrical current from flowing where it shouldn't, and bent laminations can create hotspots and increase energy loss. Always work on a clean bench. A clean workspace minimizes the risk of contamination and ensures that you can easily identify and keep track of all the motor's components. And inspect for overheating. Overheating is a common sign of motor problems. It can be caused by excessive load, poor ventilation, or internal faults, worn bearings, or burnt windings. These are telltale signs of a motor that's been pushed beyond its limits, or has suffered from neglect. Check commutators for grooves. Grooves on the commutator surface indicate excessive wear and can lead to poor brush contact and reduced motor performance. And brushes for wear. Worn brushes can cause sparking and arcing, which can damage the commutator and reduce the motor's lifespan. Preventative care keeps motors running and avoids disaster. Regular inspections, lubrication, and cleaning can significantly extend the life of a motor and prevent costly breakdowns. Know your parts and you'll fix problems before they start. A deep understanding of motor anatomy and common failure modes will empower you to diagnose and address issues proactively, keeping your motors running smoothly for years to come. Dismantling a motor is precision work. Start by documenting everything: photos, notes, tags on wires. Remove end bells, slide out the armature, and use a bearing puller, never a hammer. Cut and remove old windings, often with heat to loosen varnish. For transformers, carefully separate the core laminations and remove windings. Keep everything organized for reassembly. When rebuilding, press new bearings on, slide the armature back, and align everything perfectly. Tighten bolts evenly to avoid stress. For transformers, restack laminations tightly for a solid core. Assembly is the reverse of teardown, but with more care. Every step matters. Precision here means performance later. Take your time. A rushed job leads to failure. The details make the difference. Master the process, and you'll master the machine. This job is dangerous. Respect it. Electricity, heavy parts, and sharp tools can hurt you if you're careless. Think before you act. Identify hazards and plan your moves. Always test circuits and lock out power before working. PPE is non-negotiable. Safety glasses, face shields, hearing protection, and steel-toed boots. Use gloves, leather for general work, insulated for electrical. Lockout, tag out saves lives. Never skip it, never remove someone else's lock. Know where fire extinguishers, first aid kits, and eye wash stations are. For electrical shocks, shut off power before helping. Emergencies happen, be ready. Safety is your responsibility every minute. Don't get complacent. One mistake can be your last. A safe shop is a professional shop. Make safety your habit. Schematics are your roadmap. Never work blind. Learn the symbols, lines for wires, dots for connections, zigzags for resistors, loops for windings. Mechanical drawings show how parts fit together, exploded views, dimensions, tolerances. Use schematics to tag wires and check connections during teardown and rebuild. When troubleshooting, trace circuits and test for continuity. The schematic tells you how everything should work, follow it, and you'll find the problem. Reading these drawings is a core skill practice until it's second nature. The best techs never guess they read the map. Winding is the heart of the craft. Before cutting old coils, record every detail. Turns, wire gauge, coil span, and connections. Use the same gauge and insulation as the original, no shortcuts. Prepare slot insulation to protect wires from sharp edges. Wind by hand or machine, counting every turn and keeping coils neat and tight. Sloppy winding means vibration and early failure. Connect coil leads to commutator bars. Strip enamel, solder, or weld securely. Secure coils with wedges and banding cord. Dip and bake the armature in varnish to seal and protect the windings. Every step matters. Precision here means a long-lasting motor. Take your time. Quality beats speed. This is where skill shows. A well-wound armature is a work of art. Master this, and you're a true winder. The winding's done. Now for the final assembly. Clean the armature, skim the commutator, and undercut the mica. Remove excess varnish from the shaft and commutator. Press on new bearings, never hammer. Slide the armature into the stator carefully. Avoid scraping new windings. Reattach end bells, align marks, and tighten bolts evenly. Install brushes and check contact with the commutator. Reconnect wiring, double-check against your schematic. Test insulation resistance before powering up. Run the motor with no load. Listen for noise, check for vibration, monitor temperature and current. A smooth, quiet run means success. If something's off, stop and fix it. The test run is your proof of a job well done. Take pride in your work, it shows. You've brought a dead machine back to life. There's nothing like it. But this is just the start. Great winders develop a feel for the work, diagnosing by sound, touch, and instinct. Never stop learning. Your reputation rides on every repair. Stay organized, invest in quality tools, and keep your workspace clean. This skill opens doors. Specialize, supervise, or move into diagnostics and field service. The fundamentals you learn here apply across the electromechanical world. You're not just winding motors, you're speaking the language of machines. It's tough, dirty, and essential. Take pride, stay curious, and keep fixing. The world depends on you.